You guys recording? Yeah, good morning, everyone. Thank you for the opportunity to talk to you about YT georaster. It's a YT front end, an extension that allows you to read in geospatial raster data. So I'm Dan Eastwood. I work as a data analyst at Scottish Water, and my current role, I'm working on data improvements all the time for across the business. So I try to talk to different people throughout the business and listen to their sort of data issues and things like that. We do work with satellite data, particularly looking at weather data and things like that, but I've not had a lot of opportunity to use sort of satellite data myself in my current role. But getting back into this, YT georaster has kind of whetted my appetite, realized again the potential that we have here in this tool. So I'm excited to kind of go back to my existing work and try and think about how we can actually leverage this as well. So anyway, let's get started. So I was just going to use, in fact, I'm using every opportunity I have to include some satellite images. So I've just got a couple in our presentation today, just because, why not, right? It's beautiful images. We've got an image here from Edinburgh just this weekend, actually, when we had the hottest day of the year on Saturday. And we've got just a true color image here on the right-hand side. And then on the left, you have what is a derived field, which is the normalized difference vegetation index, which is quite a commonly used index in remote sensing, which allows you to kind of get an estimate of the sort of a basic estimate of the vegetation density. So that's something that's used a lot in geosciences to do just that. So you can imagine some of the things that we'd be looking at doing. So here's our beautiful image again, and I'm just going to use that as my backdrop as we talk through the sort of outline of the talk. So first, I'll just talk through sort of the development to date, and before moving on to kind of giving a brief introduction to geospatial data formats, because I know a lot of us won't have that sort of background, and so we can all be on the same page when we talk about the main features of the front end and what it's allows you to do. And then we'll talk through a quick example, sort of a mock example of measuring sort of coverage of green space in given areas in our area here of Edinburgh. And then I will step through sort of the ongoing sort of future enhancements that we'd like to make to the extension. So what are we doing with YT georaster development to date? So it started in 2019. It was initially a piece of work where we were working with a company called Alba Orbital, and they were interested in, they manufacture these micro satellites, these CubeSats. What they wanted to do was to look at how we could handle the data they were getting back from their satellites. And sort of as a low-hanging fruit, we thought, let's pick one geospatial format that would be useful for different teams and see if we can get that into YT for allowing you to analyze and things like that. So that's where YT GeoTIFF, which was the first sort of formation of it, was born, where we picked GeoTIFF files, which I'll come onto in a bit, to focus on. And then moving on from that, we had a collaboration with another company that I worked at called AstroSat, where Britton and Andrew Revel, who now works at the University of Zurich, I believe, were working on streamlining the workflows for the data team in AstroSat, and we were able to do just that, streamlining it so that you went from having code that could potentially be several lines to just a few lines of code to get that data ready for you to analyze. So geospatial data formats. So if anyone's worked with computer graphics, you'll be familiar with the idea of rasters and vectors. You have in YT georaster, of course, we're looking at rasters primarily, but I'll come on to vectors in a bit as well. So rasters are just your 2D grid, basically, your image. So if you think of any digital photograph, it's made up of pixels. And in our geospatial data, we want a location for each of those pixels. So with Earth observation satellites, you've got an image of the Earth's surface, and that will have a projection, basically. So you've gone from the 3D shape of the Earth's surface, and then you're looking at a photograph of it. So it's just a projection of that. And in the metadata of your geospatial raster format, you've got the transformation and the coordinate reference system, which tells you basically, along with the bounds of the image, exactly where on the Earth you're looking at. So each pixel can have a defined coordinate, a latitude and longitude, a easting and northing, if you will. And one of those examples is a geotiff file. So it just is based off of the standard image format of a TIFF, but it has this extra metadata that allows you to sort of georeference each point. You then have vector formats, and you can see the diagram here comparing the two different diagrams here that I've picked from the Ordnance Survey website. And you can see how there's this difference of you're going from your 2D grid image, and then with raster data, and then for vectors, you've got individual sort of shapes that you're drawing out with locations that you're storing in your coordinate reference system. And then that can then be used, as you'll see in a bit, as a way to sort of mask your data and perform selections. So then moving on to our main features of georaster. So georaster combines YT with the package Rasterio, the existing Python package, which reads and writes raster files such as geotiffs, but others as well. And then you can use those files however you want once you've read them in to YT. So the users can provide the data that they're interested in. Analyzing over their area of interest, they can pass YT georaster a series of files. So in my line of code here, I've got this list of files that I'm just passing to the yt.load. And then I just tell it the coordinate reference system that I want to use, or I could simply just ignore, not provide that, and it would just assume it from the first file that it reads in. But I can just say, oh, I want to work in the British National Grid, for example, and then using that, I'm able to then load the data into YT, and then at the point of making a selection, YT is then performing all the transformations, all the sort of the selection for me on the fly, and I don't have to do anything beyond saying, here is my selection, and it will worry about making sure all the rasters that I've passed at it line up. So if you imagine we've got different raster images, which can have different bands, different bounding boxes that they're overlapping to create like a mosaic. And then I want to sort of select that area. I'm able to then get all the data I need in that area through a simple selection. And then what we've got, sort of that final point here on the slide, is that we can pass any polygon or shapefile to get a selection across multiple images, like I was saying. So we simply provide the geometry that you want to select through, and then that will allow you to get the data that you need across different points in your image. So here is our sort of our walkthrough of an example of just that. So we have, with the example of green spaces, if you imagine you're looking at Edinburgh and you're wanting to understand the coverage of green space across the city. And you can look at land cover maps, which are based off of satellite data that can be provided by agencies like the European Space Agency. Copernicus have different data products, which give you kind of a mapping in a raster format of the green space, for example, or any other kind of land cover type. You can combine different kinds of products, reading them in with YT. .load, and then you've got a combination here, for example, I'm looking at the grasslands product, and then I've got the careening land cover product, and I can combine those to then create a sort of master land cover map here. And then if I just then take, for example, I've got my local authority here of Edinburgh with, and you can maybe just about make it out, there's sort of individual sub-geometries within that, which are known as intermediate zones. And if you then perform a selection within those zones of all the pixels, and I could say, okay, for all the pixels in there, I want to know how much of that is made up of green space. I can then create a map just like this, which kind of categorizes the green space within those areas. So I've got areas outside of the sort of bypass in Edinburgh, which has sort of obviously more green space. You saw in those images just how that is. But then towards the center, we have areas which are more central, which do still have plenty of green space around things like the local botanic gardens, which you'll see just north of the word Edinburgh there on the map. So it's kind of an interesting thing, and then that can be used in different ways to infer kind of information in all kinds of research. So it's kind of a useful tool that allows you to kind of perform a selection over whatever your area of interest is, and you can do that in lots of different ways. Finally, I'll just talk about some of the future enhancements we'd like to make. So here's the GitHub repo. I'll flash up a QR code at the end, which has that. But you can expand, we're looking to expand the existing dataset classes. So there are dataset classes, I should have covered that as well. The Sentinel-2, for example, is a very popular satellite in the European Space Agency. And if you pass an image from that with the known sort of file name, YT will recognize that you have a Sentinel-2 image and will select the relevant bands, name them appropriately, and then allow you to access the sort of defined fields that are built into that class. So things like the NDVI that I had at the beginning, you simply can type that I want the NDVI field and it will recognize that. So we'd like to expand that further. It would be good to have more specific dataset classes to those different satellites that would be more useful, and expand on data formats. So I'd mentioned we've got GeoTIFFs, and there's also JP2s can be read by Rasterio, but there's other Python packages that could be used to read netCDF files. I know that there are other front ends that kind of cover that as well in YT, so it'd be interesting to see where those could be combined to handle the sort of geospatial side of things. And then finally, it would be good to be able to query by multi-polygons. So currently, we can make a single selection with a single polygon. And it would be good to have it so that you could provide like basically a combined polygon where they could be discrete polygons in a space on your map, and have the selection kind of do that in one rather than having to do multiple selections for each one. But yeah, thank you very much for listening. Any questions?
Have any questions?
I do have a question. I'm curious if you deal with any multi-resolution images like image pyramids or anything like that, or are you dealing just with that?
So you can do that. So there was something there on that last screen, which is the sort of virtual raster data sets, which would be something to add in the future. The way that it works with YT georaster is that you can pass all kinds of images from that, which could have different resolutions, but I think each image would just have one set resolution. Yeah.
My recollection is that some of the images that we loaded had like 10 meter and 20 meter resolution.
Yes. Yeah.
We could query them
right.
by like band 8_10.
Yeah.
Band 8_20. Get them. But you can load in two images with different resolutions. And whichever one you load first is the base, is like the base image. So when you query a data container, if you query a field from the other image, it will be repixelated into the base image. then you can flop the order at load time to do it the other way. And there might have even been a way to do that mid without
Yeah, it
changing.
included a sort of was it a scale factor that allowed you to kind of scale up or down the resolution to whatever resolution you needed. So
That's right.
Can you control the method used to do that?
yes, I think that was added. So basically anything that's natively covered by Rasterio, I think kind of allows you to, you can do all of those now
Rasterio is doing all the work.
Yeah, yeah,
under the hood, I think.
to read it. Yeah.
Correct. I actually am not sure if maybe multi-polygons do work.
Yeah.
Yeah, I think they might. At least one of the examples I have in a notebook
Yeah.
is a shape file that has multiple disconnected
Yeah.
items.
So it might
But
work.
are they different
So
geometries? Like if each of those is a separate.
Yeah. That's basically what I did here. Yeah, these are single geometries, but it was in one shape file.
Okay,
But then
to multiple shape files.
yeah, so I could do everything I needed to do to make this calculation, but I had to basically pass it as like, okay, now do this, or polygon, now do that polygon kind of thing.
Right.
Which, you know, it's it may be useful actually for most use cases because you actually do care which polygon you're talking about, but
Yeah.
there'll be scenarios where you just want to say, you know, if you had, like, for example, we've got these islands here,
Yeah.
and you were trying to make a selection for the whole local authority, including those islands, and you wouldn't be able to do that, I believe, with the current setup. But I think it is just a
Analogy for me. Has a list of like data objects and what normal YT where you wanted separate results from each data object.
Right.
If you had a list of spheres.
I understand, yes.
to tag them.
Okay.
Get all the spheres.
Okay, that might be just out of our capabilities at the moment. We're probably not far away.
How reusable is the polygon selection? As in, like, if I had a 2D, could I reuse some of the code that's used for polygon selection? Or
Believe so.
I think so,
Yeah.
because essentially we're letting Shapely do most of the work. We're telling us what is inside this shape.
That's right.
And then we have a very thin translation layer to YT to take that to that. I think should be quite reusable.
Yeah, and it should be, yeah, like agnostic to the fact whether or not you have a coordinate reference system like that or anything.
useful when you have an image, sometimes you want to select a region that is not. That
That's
is
an
just
excellent point.
that is just like it's
Yeah.
shaped.
One of the other things we did here is we spent some time kind of making a lot of 2D extra helper things, right? So we implemented circle and rectangle as 2D selectors. So I think we could, in theory, probably abstract some of that to like a 2D dataset class and take that out of the front end. I think we implemented a lot of general stuff in the front end for 2D things that could be generalized. Any more questions?
Go for it.
What's lacking from Raster.io, or what's the addition of YT?
Well, I think YT can deal with things over those different scales. And you've got I mean, like you can do all these things with your Python code, right? If you use Rasterio, Shapely, you can do all of that. But what YT does, it kind of streamlines that for you. So it's handling all of those steps. So that's a great question.
I think another answer is that YT has all these other specialized ways of selecting data by geometry and by other criteria that, when linked with this, allows you to do that here as well. We had a couple videos actually from about that. Yeah, I think it's really that YT makes a lot of that stuff a lot easier, a lot more straightforward to do, and maybe more portable. It's certainly code that someone could write, but we've implemented a lot of things in fairly smart and robust ways.
I think the main selling point for me was being able to handle data from some arbitrary grids. CRS
Right.
systems and just to natively, do all that. On the hooks, you'd have to worry about how you reproduce. I think that was.
We buried that at just the right
Yeah.
depth and provided, but still provided users ways to do that made it usable. Any more questions for Dan? All right, this is awesome. Thank you, Dan.
Yeah, no, thank you. Thanks everyone. Also recording?
Oh, yeah.